Alright guys, this is actually a printout from your textbook. It's in the back of the chapter. So if you're ever, I talked about this before, but I recommend that you go to the back of the chapters and do problems there before you're doing them on mastering, because these are not worth any points, but the ones on mastering are. And I also do want to point out that if you did not purchase the solution manual, you're still probably okay, because I do believe they have like the red highlighted problems in there that are in the back of the textbook. So you have the solutions. The optimal thing, though, is to go ahead and just get the solutions manual, but it's kind of a expensive book there if you're not using it all that often. So it's up to you. So I want to go ahead and I think I want to look at this one here. So 1.29. So I just want to show you guys a little bit on how we should approach word problems. So just fixing the zoom here so you guys can actually read it. All right. So the thing that I like to do is when I first see that, I just imagine a big wall of text. So I like to pick out the pertinent information. Basically, before I start picking to the data that's given, I want to think about, okay, what is the question actually asking me? Because as you guys that had me last semester probably saw that sometimes I like to throw in extra information that you don't need, just to see that if you guys know how to use the information that you're given, you're able to pick out exactly what the question is asking you. You're not just kind of memorizing and regurgitating an equation. So I want you guys to actually learn chemistry, not just learn how to crunch numbers in an equation. Anyway, looking at this particular question here. So it says a sample of the tetrafluoroethylene is used for blah, 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 background information. Okay, so here we have mass, volume, temperature. What is the density at this temperature? Okay, so I'm going to go ahead and highlight that. So what is the density? So I'm going to then go ahead and look at the information given to me. I'm given a mass, a volume, and a temperature. Do I need the temperature in this equation? Nope. So the question is not as saying what is the density at this temperature. Yeah, the temperature is relevant, but we don't need it to answer it because it's basically saying the density at 25 degrees C. And typically, what are the units on density? They're typically grams per mil. And then another thing I like to think about too when figuring out my numbers here, I am seeing that we don't have to do any conversions here. So we need this number, I don't need that number. So I'm just going to go ahead and rule it out, and I think I have enough stuff here to answer the question. Oh, another question for you guys is the identity of the compound important in this question to answer it? No, it's not. Yeah, it definitely is relevant, but we don't need it to answer it, so don't let that confuse you. All right, so this is a pretty straightforward question. It says, what have a mass of this amount? So showing up, okay, density is equal to mass over volume. So we go ahead and take our 40.55 grams, and we have 25.0 ml. And as I mentioned just a moment ago, our units are going to be okay. So let's go ahead and carry out the calculation, and then after you do the calculation, you then worry about sig figs. All right, so 40.55 divided by 25, I am getting 1.622 for that. So let's go ahead and write the whole thing out. 1.622 grams per ml. And how many sig figs should my answer have? Should be 3. So you take a look at the numbers here. These would both be quantities that were measured. They would not fall in the category of table information. There's something that was measured. So they're both relevant. So it looks like 3 sig figs is the limiting factor due to the bottom number here. So 1.62 G per ml. All right. Next question here. It's actually part of the same question here. Will tetrafluoroethylene float on water? And what do you guys think? No. It turns out that if it's more dense than water, it's going to fall to the bottom. And if it's less dense than water, it's going to go to the top. And I think I did mention a little bit about if you have like two liquid mixed together, like which one goes on top, and that becomes an issue in organic chemistry, not so much here. Do you guys know offhand if you mix oil and water together, which one goes at the top? What's that? Oil goes at the top. Oil is less dense. In general, organic compounds, these carbon-containing compounds, things like oil, gasoline, things like that, they tend to be less dense. That's not always true. There are exceptions to that. But in most cases, the organic stuff goes at the top. That's actually why if you go to the gas station when it's been raining outside, you typically see like this kind of metallic sheen on the water. I'm sure you've ever noticed that at the gas station when it's raining out. But it's actually from all the oil and spilt gasoline on the ground coming to the top, kind of floating on the top. It's also the reason why it's so dangerous to drive here right after it rained in Las Vegas, because of the fact we don't get much rain. So when we do get rain, the oil is kind of sitting on the surface of the road, and then when you come to a quick stop, you slide. Where if you wait like an hour or two, or just a while after it's raining, it's not as slippery out because it's had enough time to run off. And you don't have this problem as much in places where they get rain often. It's typically places like the desert where we don't get much rain. All right, little side note there to answer that question. Next question here, as part of it, is carbon dioxide is a gas at room temperature and pressure. However, carbon dioxide can be under pressure to become a supercritical fluid. That is true. That is a much safer dry cleaning agent than this. So I do want to mention a little side note here, being that it's kind of relevant in current times in Las Vegas. So marijuana being a big deal right now in Las Vegas. It turns out that before they used to, thinking back to making decaf coffee, people used to use organic solvents to pull out the caffeine. And they would just treat it with like a dichloromethane or ether. But the downside of that method is that you have trace amounts of it. And what they do now instead is they actually make supercritical CO2, and they can do the organic extraction, you need organic solvent to pull the stuff out. They pull out the caffeine, and then all they do is let it warm up, and then naturally it just all kind of goes away. And then if there's trace CO2 in there, big deal, it's in the air anyway. And it's actually one of the main methods now they use for making those concentrated extract of THC now, is instead of using organic solvents, they're now able to use a supercritical method. And the good thing about